Hi Prof. and friends, we will be reviewing a journal about the use of square wave anodic stripping voltammetry to determine heavy metal concentration in mussels and clams, which was formerly done with atomic absorption spectroscopy. Mussels and clams can act as environmental biomonitors since they continuously uptake heavy metals from the water in which they live. Easy and accurate determination of the trace heavy metal is critical because they are part of our daily diet. Now let's take a look on how both of the techniques may work according to the paper. Now let's take a look at how IAS work. The flame of temperature 1900 to 2500 K atomizes the analyte and the atoms are irradiated by hollow cathode lamp. Specific radiation emitted by the atoms passes through a monochromator in order to separate the element-specific radiation from any other radiation, which is finally measured by the detector. Now let's take a look on how ASV works. 3 electrodes are employed to measure the cells. Gold and hanging mercury drop working electrode are used separately. Mercury 2, copper 2 are measured at a gold working electrode, while copper 2, lead 2, cadmium 2, and zinc 2 are measured at a hanging mercury drop electrode. A silver-silver chloride reference electrode ensures the potential of the working electrode is maintained correctly, and a platinum counter electrode completes the current flow of the circuit. The supporting electrolyte is 0.0 molar EDTA, 0.0 molar sodium chloride, and 2 molar perchloric acid. The technique involves 2 main steps. The first one, where the positive ions are deposited onto the working electrode via reduction by applying negative potential in a stirred solution. The second one, the stirring is turned off, and then the potential of the electrode is scanned into positive direction so that the deposited metals are oxidized back into the solution, which then generates a current in microamps. The amount of the current is proportional to the concentration of metal ions in the sample. The result, the 2 figures shown here are a voltammogram of toxic metal ions at gold electrode and hanging mercury drop electrode. In the first figure, the peaks are mercury 2 and copper 2. In the second figure, the peaks are copper 2, lead 2, cadmium 2, and zinc 2. There is a good agreement between the square wave anodic stripping voltammetry and atomic absorption spectroscopy results, as all the percentage differences are lower than 10%. This indicates that voltammetry indeed provides a sensitive, reproducible, and accurate response for simultaneous metal determination as stated by the authors. Positive aspects. Number 1, there is a method validation. Before applying the analytical procedure to the real sample, the authors analyzed the standard reference materials to confirm the applicability of the proposed analytical procedure on ASV and AAS. The figure depicted on the slide is a comparison between the certified value and the determined value in microgram per gram using ASV. The relative standard deviation and error are satisfactory because they are lower than 6%. The blanks refers to undetermined overlapping peaks of the copper 2 and mercury 2 on gold electrode. Number 2, limit of detection. The authors established a limit of detection of each element in both aqueous reference solutions and standard reference materials based on analytical calibration function at K equals to 3 and 98% confidence level. The blanks refers to again undetermined overlapping peaks of copper 2 and mercury 2 on gold electrode. Critical aspects of the paper. Number 1 is the overlapping peaks of copper 2 and mercury 2 in the method validation with standard reference materials, so limit of detection can't be determined. Our recommendation is to try out what other types of condition where peaks can be resolved. It is not known what kind of conditions that can be used in order to separate the peaks, but authors can carry out experiments looking at the empirical observation to determine the best condition for the good resolution. This resolution has been observed in other metals by Ribach et al., which was published in 1993. They managed to do the peak separation by varying the conditions. Number 2, there is a contradictory statement made by the authors whereby they state that voltammetry has a good selectivity, but in fact, some peaks are overlapping as mentioned above due to unfavorable concentration ratio of the 2 neighboring metals. Number 3, comparison with other methods of analysis such as ICP-MS is suggested to further validate this method. In conclusion, the authors have successfully employed the voltammetry technique with 2 advantages over atomic absorption spectroscopy. Number 1 is a simultaneous metal determination, and number 2, the lower equipment cost although signal interferences are observed. Thank you for watching our video. We hope that you enjoyed it.